Oh yeah, thank you for the introduction. Yeah, so me and my team, we looked at the bridge inspection process in Germany and thought about how to optimize it. So first of all, how did we go about it, or why do we do this? It's, yeah, bridges, be it due to aging or traffic or climate change. Eventually, something's gonna break. And the earlier we can see when the earlier we can detect damages, the easier it's gonna be to repair them. So in Germany, the bridge inspection process is still mostly paper-based. So some guys running around with stacks of papers, trying to detect the damages and writing them down. You can imagine the work they have to do after that with even more writing. It's time consuming. So we thought, okay, let's go there and see, can we optimize this and make the work for the inspectors a bit easier. So how did we go about it? First off, we did a detailed analysis of the DIN 1076, which is a norm for us Germans where the guidelines are on how to do a bridge inspection and what there is to see and what there is to do. Secondly, after the analysis, we looked and said, okay, these are some potential process steps which could be optimized with either AR or AI, and then took them and went to some inspectors, some bridge inspectors, and said, here, look, we have identified these. Can you think, or do you think it will add value for you? And lastly, we also did a hardware analysis, so which hardware would we want to use there, which would be appropriate to use. And yeah, after that, we decided. So the first point in the interviews that we got was to the hardware, and of course, like my pre-presenter also said, safety precautions are very, very important, be it on a construction site or by bridge inspection. So if we use hardware, it should not get in the way of the safety precautions. So, secondly, they told us that in Germany, normally we have 2 inspectors on site. That's recommended, it's not a rule, but normally we have a minimum of 2 inspectors for safety reasons also. And this is where we decided, okay, when using AR, it would be nice to have it more immersive, like with the HoloLens. But the HoloLens is not the tool for documenting stuff, because you have a very small screen you can work on, and the input methods are, yeah, let's just say not that intuitive. So we said, okay, we have 2 inspectors, why not use 2 devices and take the advantages of both? So we took a tablet and the Trimble HoloLens 2. So the Trimble HoloLens you can see in the picture below. There's, for the safety precautions, also a helmet. The HoloLens is integrated into that. So at least the helmet is there, the safety precautions are met. So let's just look, like I said, we have 2 applications, so one for the HoloLens and one for the tablet. Let's just look at the HoloLens application. So 2 other requirements they said they wanted to use were, firstly, please track and overlay damages from previous inspections. So last year there was someone, he detected the damage, please try to find it again and highlight it via the HoloLens. Or if we want to make a new picture or document a new damage, please get us AI support to track the damage. And as you can see, we have a little block with us. There's a crack, and you see what the HoloLens user would see at the moment. And this is that the crack is outlined where the crack is. And this is what we can see. And our AI it can detect cracks, erosions, honeycombs, and spalling. And this damage detection, someone from our chair, they developed it, and we used it for our purposes in this paper. And for the damage detection, the paper, there's also going to be one, but this is soon to be published. So furthermore, like I already said, we also want to redetect previous damages we found. So we can use, and I think a bit from that we also heard about, we can use the HoloLens to make rough laser scans, or also named spatial meshes. So every time we detect a damage, we record a spatial mesh with it and save it with the damage, so that we can make, so we can put an anchor down and make an elastic anchor network of all the damages we detected on the bridge. So we can more accurately say, okay, this was this damage from the spatial mesh we have and from our surroundings, from what the HoloLens sees. So then, what can we do to record these damages? So, of course, one point was from the inspectors, they said, yeah, please, we want to make photos. We want to make images of the damages. So please give us the option to make a photo of the damage. And please don't clutter the interface. And we also want to have everything just on demand, so we have a very clear view. So first off, as you can see, the menu, we can just, we open it with the hand gesture shown on the slide. And a menu will open that is tracked via the hand. So the menu will follow the hand, and when you don't need it, just turn your hand around. And what you can do is you can take a photo with the first button, and you can toggle the overlay of the AI. So you can turn it off and on when you need it. Lastly, you can send the pictures and the photos you made via a button to the tablet application. In the tablet application, we then have a tab where you can import the pictures and damages from the HoloLens users and fill out the required fields like where is the damage, on which component is the damage, at which separated on which bridge is this damage, etc. And if you then import the images, you also get to an interface. The interface, the requirement for that was that everything we need in the DIN 1076 specification, we should be able to write them down there. So as you can see, we have a blueprint of our bridge. At the moment it's just empty, but we can also just put down some pins on the blueprint and say, okay, here's the damage. We can name the damage. We can, like I said, everything that's important, like what type of damage is it, how big is it. We can also make an evaluation of the damage severity. When we think, okay, that's a pretty evil crack and maybe we need to close down the bridge, then we have also the option to make a comment in a comment field. So lastly, we also got an overview of all the documented images. Here you can see the pins with the little eye symbols. And you can then look up, okay, when was the last inspection? And then there will be all the damages on maybe different blueprints and where they are on the bridge. So lastly, to use this concept, we also needed to adapt the concept a little bit from the DIN 1076. And of course, we have three layers. We have the data layer. First, there is the obvious database, the zip BW database. This is where the old data or every data about bridge inspection is saved. with us, and then we also needed to adjust because we also needed meshes, and the zip database was not meant for these meshes. We also need a second database that is connected for the meshes we save from the HoloLens. Then in the office, of course, we need to put those databases together and put them on the tablet so we can use them on the on-site bridge inspection, where we then have our two inspectors. We call the data inspector, that's the one with the tablet, and the visual inspector, which is the one who is carrying the HoloLens. Of course, they also can switch if they say, okay, this Trimble HoloLens 2, it's very heavy because there's a helmet, and then there's the HoloLens, it can get very heavy. So they can switch in between if it gets too heavy to wear the HoloLens. So, like as you can see, the tablet user can also then sense the data from the previous inspections to the HoloLens, so the visual inspector can see and evaluate older damages and take newer ones with the help of the AI assistant who can help him detect the damages and measure the damages, then records the pictures and sends that back for the complete data inspection so that everything can be done, and then it goes back through the office. It gets prepared for the transfer to the databases. So in conclusion, what did we do? We conducted some interviews to identify the potential inspection steps to be optimized, and with these interviews, we developed a concept to digitalize this bridge inspection process. This is, at the moment, research is still ongoing. At the moment, we are at the point of developing a demonstrator for real use, for testing. And with this demonstrator, we'll go to bridges where we will test if it really works, or how good it works. And this will also, everything will be evaluated by experts. So some bridge inspectors we will get, and they will say, okay, yeah, it's good, or there are some problems, or yeah, no, we don't want to use new technology. So lastly, all this work is funded and is done on behalf of the BAST. That's the Federal Highway Research Institute in Germany. Thank you for listening.